Okay, how are you everybody who is watching this fantastic content or video content in the field of engineering? I would like to take this opportunity to welcome some physical engineering students and some physical, also we call them lovers of electronics engineering. And also I would like to take this opportunity to welcome non-physical students or those students who are not physically connected with me when we are learning this content. It's the first time to meet me. My name is Olenjolain. I'm very happy to have you. And I prepared the good news about electronics engineering that I would like to share with you. So I would like to welcome you in our module or departments of electronics engineering. We have our online college that called it Tanzania Online Full Technical College. In short, we call it TZFTC. When you say that full technical college is actual that we are going to discuss about theoretical concepts of the engineering mathematics, especially basic engineering mathematics, basic electronics engineering, basic telecommunication engineering, basic electrical engineering, basic computer engineering, basic mechatronics engineering, and even basic biomedical equipment engineering. So I would like to tell you that these contents are very important. And we are going to learn a particular technical language that's called the electronics drawing. That's why the modules is called the electronics drawing. We are in departments of electronics engineering, and we are ready to enjoy, or we are ready actually to learn the new concept to add up the value on what we have been learning. So we have been going through lecture 0, lecture 1, lecture 2, lecture 3, lecture 4, and today we are in lecture 5, where we are going to learn about types of electronics drafting. We have the topic, this is chapter 1, which is actual that we are going to focus on introduction of electronics drawing. So we have to finish up this chapter or this topic, so we may start the next topic. That's all about electronics. That's called about the block diagrams. That's the next topic after this one. I want to tell you that this is a serious course. You should have drawing tools, and also should have a fresh mindset, and you should be actual in positive way of accepting and learning and apply the information that we are going to share with you. So I don't want to actually to spend much of your time. I think that you still have some introductory issues. Right now it's better to go and put in practice what we are saying. So let me appreciate some physical engineering students who are actually pursuing ordinary diploma in electronics and telecommunication engineering at the DIPLOMA Institute of Technology in departments of electronics and telecommunication engineering, where actually we are training them physically this module. And then after that, we are going to start our lecture 5. And we'll start with the quick review. So how are you, electronics and engineering telecommunication? How are you, electronics and telecommunication engineering students?
We are fine.
No. How are you again?
We are fine.
Well, are you ready for lecture 5?
Yes.
Well, so if you are ready, let us start our business. Let us start with quick review of quick review of lecture 4. So lecture 4 for electronics drawing, actually we learned about, first of all, the title of this lecture is actually called the types of what? What the types of the lecture? Types of what? Electronics what? Drawing. Electronics drawing and what? Electronics what? Drafting. Then we say that there are so many, or there are different types of what? Of electronics drawing that we have in electronics. But we say that we have to discuss some of them. And each of these drawings is actually giving you important information concerning about electronics. So that's why that each type of the diagrams or of the drawing actually is very important to give you particular information. The first types, we say that block diagram. This is the first type of electronics drawing. Say block diagram. Then we say block diagram. Say again block diagram. Block diagrams is actually show high level of the information. So this one is show high level of the information. It shows high level of the information. So it shows the high level of the information by using blocks, which represent subsystem, by using blocks and arrows, where arrows show the signal flow or the flow of the current or the flow of electric signal from one block to another block. So you're using blocks and what? And arrows. Then if you do remember that, I gave you a simple example of what? Detailed block diagram of linear power supply, which actually consists of 60 blocks. The first one is called the AC mains. The second one is called the step-down transformer. And the third block is called the actual rectifier unit. And the fourth block is called the filter unit. The fifth block is called the regulator unit or voltage regulator unit. And the sixth block is called the loads. So I'll discuss them later on, but I say that it's better to introduce it to you. So that block diagrams here are the 60 blocks as an additional of the general block diagrams of any electronics system. Then after that, we discuss the second type of electronics diagram, which we call schematic diagram. Class A schematic diagram. So this is a visual graphical, or we call it a visual or graphical representation of the particular idea by using standard schematic symbols. Standard schematic symbols, or standard electronics schematic symbols. And also it uses what? Wires to show the flow of electric quantity from one point to another point. So the subsystem for this case, for the schematic diagrams, will be represented by electronics components. So electronic schematic symbols of electronics components. Electronics components. So electronics components are the one that will be representing what? The subsystem of that particular system. Right? Right? So we don't have arrows in schematic diagram. We don't have blocks in schematic diagram. We just have schematic symbols of electronics components and the wires. Then the third type is called the circuit diagram. Say circuit diagram. Say circuit diagram. So also circuit diagram use standard electronics schematic symbols of electronics components, but it has electronics components, but it has what? It has some additional features, and these additional features, it means that it also includes values of electronics components. So values of electronics components, and we discuss about these values, such as resistance, such as inductance, such as what? Inductance, we call it L, such as capacitance, such as what? Such as current, and such as voltage gain or voltage, such as power, such as voltage gain, etc., etc. Then the last, it was in the last, we are discussing about the common examples, or we call them the main examples, the main types of electronics drawing. So the last one in that discussion is called the functional block diagram. Say functional block diagram. Say functional block diagram. And then in this one, we say that this is the type of block diagram in which the diagrams or the information is represented by using blocks and wires. Sometimes there are the arrows and sometimes there are the wires. So for this one, we are using blocks. In some cases, we are using arrows. And in some cases, we are using just the wires. But remember that these blocks will be representing function. So if you have a particular system that can perform different function, or you have a particular system that performs a particular function, then you can break down that main function to be sub-function. And then once you have that, you can use the functional block diagram to represent the idea. And then I left the homework for you. Draw the functional block diagram of a digital accelerometer, and I made a demonstration to you. What does it or what is digital accelerometer and how is it working? So I checked what you have found. Some of you have found just a common diagram, but you have to make sure that you draw the functional block diagram of ADXL 335. Yes, because you have ADXL 335 and ADXL 345, something like that. And it looks kind of, just looks like it's a little bit challenging, or it's a little bit interesting, and it's completely different. So because I know some students, they may confuse it, and we say that this functional block diagrams is always found in data sheets of electronics components. Okay? So because that some students may confuse it with what? With block diagram. Functional block diagrams is completely different from block diagram. So let us draw the block diagram or the functional block diagrams of that ADXL 335. 335 or 345? I'm not sure. Either 345 or 335. Something like that. 335 or 345. Either 3 or 4. So I'll cross-check about that. So how do we draw these functional block diagrams? It's completely different from block diagram. First of all, for this functional block diagram, we have a frame. So this is lecture 2. Before we discuss about types of electronics drafting, let us draw this example functional block diagram. So at least you have it in your mind. You should not say that I just heard it, but I have never seen it. And the teacher just mentioned it and did not give us even one example. So this one we call it voltage across source. This one we call it voltage across drain. Then here we have power management. We have a block that's called the power management. Power management. Power management. So here we have a block that shows real axis. 3 axes. This is the sensor. Here you have another block. Sensor electronics. Who is talking? Naomi, eh? Naomi. 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 Are you the one who is talking? Who is talking? Your neighbor. She's not talking. Possibly that is Nehemiah of Bongoland. That is Nehemiah of Bongoland who is talking. Or Jackson. Jackson of Bongoland. So then we have some wires or some flow of electric signal. Then we have another block. Digital filter. Who is that? Eh? That is Jackson, eh? Eh? Jackson, why are you disturbing my class? You are not studying? Eh? What are you drawing? Eh? Functional block diagram. Of what? Eh? Of oscilloscope. Eh? Accelerometer sensor. But Jackson, you told me that you showed me your drawing. What happened? Eh? You are drawing the other one. How about yours? Eh? Yours has disappeared. Eh? Separating, so growing. So this is the simple example of functional block diagram. I say so growing, separating. Listen and watch. With this, so you may notice that simply what you have to note, not just you have to know about interrupting or what has been written. Let me just define some terms, and then the aim of this figure 4 is just to show you the difference between block diagram and functional block diagram. That's all. Right now, you are just beginning the course. You are just your NTA level 4. You don't know anything about sensors. Maybe it's a new phenomena. So the intention is just to see the shape or the appearance of the functional block diagram. How is it differ from block diagram? That's all. Okay? Not just to know about those axes or whatever. So when you start, this is 3-axis sensor. As we say, this you find that it's y-axis, this is x-axis, and this is z-axis. So it's 3-axis sensor. So it actually works or provides acceleration in 3 axes. Again, we have that this is sensor electronics. So this is the part that each actual will be sensing. This is actually focusing on orientation. And ADC, it's abbreviations of analogy to digital converter. Analogy to digital converter. Say analogy to digital converter.
Analogy to digital converter.
Say analogy to digital converter.
Analogy to digital converter.
Cosmos yourself. Say analogy to digital converter. Are you Cosmos? Cosmos yourself. Say analogy to digital converter. Eh? All students say analogy to digital converter.
Analogy to digital converter.
So that the abbreviations of ADC. ADC means analogy to digital converter. Mr. Younger, Mr. Younger. Then this one is digital filter. Say filter. Say filter. We always used to prepare or to cook some tea at home, isn't it? Eh? Who like to drink tea? Did you take some tea before you came? Did you prepare yourself or somebody prepared it for you? Somebody prepared it for you, eh? Because you're a big boss. You just have to pay him or her. Oh, well. There's no payment. So, once you prepare some tea and put some tea leaves, then you have to separate the tea and the leaves. We use something we call in Swahili kichujio. Do you know chujio?
Yes.
If you don't know, you don't like tea. You like, did you use chujio last night when you have been eating rice and beans? No. You use chujio when you are taking some tea. Did you use chujio this morning? No. What did you take in this morning? Something wonderful, eh? Water. Okay. So filter, this is an electronic system which is actually filtering the signal. So when you use maybe for example that we call it the T filter. When you're using the T filter, its main function is actually to separate the T and the leaves. Hello? I gave you 3 days to draw that diagram. You did not draw. And now once I drew, you want to be expert on drawing. So the main function of the T filter to separate the leaves, the tea leaves, and the tea, right? Kazi ya chujio ni kutenganisha chai ambayo najua unaipenda, si ndio? Once I mention chai, you know what's happening to your enzymes, is it? I need it right now. I need it right now. Okay? And woti na majani ya chai. Kwa kazi yake inatenganisha. Unapoweka hapa, majani yanabaki kwenye chujio, chai inakwenda kwenye kikombe. Si ndio baada hapo unajua nini kinachofuata. Hiyo chai haipozwi, inaenda kupolea wapi? Tumboni. Kwa hiyo tunaposema digital filter, that is how it works. Then we have 32 level. Say 32 level. Say 32 level. So this is a digital circuit. And then you have serial, input, output. I/O is the abbreviations of input, output. Say serial, input, output.
Serial, input, output.
So this is the communication protocol. One of the communication what? Protocol. In electronics communication, we have a number of protocols. Right?
Yeah.
When you talk about protocols, we are not talking about political protocols, no. We are talking about technical protocols. Then another block is actually called the control and interrupt logic. You say control and interrupt logic.
Control and interrupt
Hey! Hey!
logic.
You okay? Yes, hopefully you're okay, but you are not okay. Today we have Mr. Of course number 2, Mr. Nehemiah. So the man was not okay. Yes. But you could say that I'm okay. Sir, do you have parallax here? Okay. So then say control and interrupt logic. That's a very important block for this digital accelerometer sensor. Then VS is abbreviations of voltage across source. Say voltage across source.
Voltage across source.
Source is the one of the terminal in field effect transistor. Then this one VDD is abbreviations of voltage across drain. Say voltage across drain.
Voltage across drain.
So drain is another terminal of the field effective transistor corresponding to the collector in case of the bipolar junction transistor. Then we have another part. Then we have some parts. These are the externals. These are the externals. Actually, these are the external pins. This is INT1. INT1 is abbreviations of interrupt. Say interrupt.
Interrupt.
Say interrupt.
Interrupt.
So this is interrupt pin, and also this one is another interrupt. So you have interrupt 1 and interrupt 2. Say interrupt 1 and interrupt 2.
Interrupt
Stand up.
1 and interrupt 2.
Yes, stand up. Yeah, yo, stand up. So you can stop drawing. Then this is, so for this point we have connection between serial, the SDA, say SDA.
SDA.
Very important electronic terminology. It's an abbreviation of serial data. So it's called the serial data pin. Say serial data pin.
Serial data pin.
And this one is abbreviations of serial data output pin. Say serial data output pin.
Serial data output pin.
And then this one is abbreviations of SCL. It's called the serial clock signal. Say serial clock signal.
Serial clock signal.
Those serial clock signal, you hear about clock signal, you hear about the interrupt, you hear about whatever. That's all about digital electronics. So simply, that's what has been presented. And this is the ground pin. Say ground.
Ground.
Yeah, so grounds of this. So this is the ground pin. And some of the blocks will be connected. But remember that we're not showing the block diagram, the schematic symbols or schematic components or schematic symbols of electronics components. But again, this is what? CS. CS, it means that this is clear. We call it clear selector pin. Say clear selector pin.
Clear selector pin.
Yes, so those are the parts of that functional block diagram. So you may notice that the way it looks like is completely different from what the general block diagram. In block diagrams, in most cases, we have single arrows. First of all, we have arrows. But for this case, you see you have arrows and also you have wires. Okay?
Yeah.
But also you have kind of distinguish the arrows. This one. We are not using them in block diagram. But again, you have the frame, the part, just the frames for the external connection. So in case of the block diagrams, we don't show like that. And in case of the block diagrams, you have to show the flow of the signal from the beginning to the end. So you may notice that it's completely different from what. So each block, how many blocks do you have there? How many blocks? Stand up. How many blocks do you have there? Stand up, all of you. How many blocks do you have there? So each block perform a particular function. Each block perform particular
function.
Each block perform particular
function.
Each block perform particular
function.
That's why we call it functional block diagram. Have your seat.
Thank you.
Okay. So after, let us discuss some more types of, let us focus on types of electronics drafting. So you may keep on studying about what we've been discussing, but let us have a focus on this. Types of electronics drafting. Say types of electronics drafting. Again, say types of electronics drafting.
Types of electronics drafting.
Well, so you say that that is number 4, the function block diagram. So number 5, so you say that there are different types of electronics drafting. There are different types of electronics drafting. So the following are some of the types of electronics drafting. Following are some of the electronics drafting. So this will be number 5. It's called the PCB, or printed circuit board. Printed circuit board. Printed circuit board or PCB board. Printed circuit board or PCB board. Layout diagram. Layout diagram. Layout diagram. So the first example, or the first type of electronics drafting is called the printed circuit board or PCB layout diagram. Say printed circuit board or PCB layout diagram. Say it loudly.
Printed circuit board or PCB layout.
Again, say it loudly. Printed circuit board or PCB layout diagram.
Printed circuit board or PCB layout diagram.
So what is it? We have discussed about that. Malaika, what does it mean? You forgot. It's what? It's a board where the components of the circuit are put or stored. So the board is stored the components. So you say that a PCB, we don't mean about combination. A PCB layout is a drawing or is a diagram that represent, so this is the diagram that is a diagram that represents how electronics components present how electronics components are placed, on the physical board. On the physical board. How electronics components are placed on the physical board, and how electrical traces connected them. Electrical traces or roots connected them or connected their electronics components. Separating, listen and watch on the blackboard or listen and look on the blackboard. So a PCB layout, this is the type of diagrams, or is a type of electronics drafting diagram that represents how electronics components are placed on the physical board and how electrical traces or electrical routes connect the electronics components. So in PCB board, we have three terminologies which are very important. You have to be familiar with them. However, that we'll discuss in detail later on. The first one, we have just the electronics components. Electronics components. When you say electronics components, just like a diode, transistor, resistors, capacitors, etc. Then, the second terminology that commonly in PCB board, we have something called it holes. Holes where that we place those electronics components. So holes where we use to place the electronics components on the surface of the PCB board. But also we have another common terminology which we call it traces, or especially in CAD or computer aided design, we call them roots. So roots this we use copper material to connect one component with another component. So you're using copper. So in those PCB boards, either it is single-sided PCB board or double-sided PCB board, but they have copper material. I said stop writing, stop drawing. So these are the roots. So the roots or traces replace physical wires. Replace what? Physical wires. So for instance, you need to connect maybe one resistor 1. For instance, that you have resistor 1, or you have resistor 1. For instance, this is resistor 1. This is terminal 1. This is terminal 2. And also here you have a general purpose diode like this one. Then this is terminal 1 of this diode, terminal 2. Or this is anode, this is cathode. Then you want it to connect to terminal 2 of resistor 1 and the anode of the of the diode. So if you place these electronics components on the PCB board, then to connect the anode of the diode and terminal 2 of the resistor, you just need a root. So this is what we call a root, and it's not a wire, it's a root. And this root is achieved by using copper material found on the surface of the PCB board. So this is what we call the root or trace. That's why you may notice that in modern PCB boards, you don't see a lot of wires. You just see thousands of electronics components which have been placed and mounted and soldered on the PCB board, but you don't see wires. For instance, if you open your mobile phone, then you notice you'll see the electronics components and the PCB board. That's all. It means those electronics components are interconnected together by using roots or traces. Electric roots or traces. Say electric roots or traces. Say electric roots or traces. So when you talk about electronics components, this is the electronics components, this is the electronics component. When you talk about holes, we discussed in previous lecture 3, that in order to place resistor 1 onto the PCB board, you need a hole. Okay? Yes. In order to place this terminal 2 of resistor 1 into the PCB board, you need a hole. In order to place anode of the general purpose diodes on the board, you need a hole. In order to place cathode on the PCB board, you need a hole. That's what we talk about holes. And the dimensions of this hole should be equal with the dimension, or should be large. The size of the hole should be large rather than the size of the terminal or the pins that will be placed. Okay? Okay? So we talk, I mean that with this simple example, we discussed about electronics components. We discussed about the holes, where actually, because in electronics, we have through holes electronics components, and also you have surface mounting device electronics components. Or in other words, you have through-holes electronics components and you have SMD electronics component. So the through-holes electronics components, if this is the PCB board, the through-holes electronics components need a hole so that you can place or you can mount that electronics components, and that pin or that hole or that terminal should be on another side. Suppose that this is the PCB board. We have different types of PCB. I say this, stop writing, stop drawing, listen, watch. Suppose that this is the PCB board. In electronics, we have single-sided PCB board. We have double-sided PCB board. We have multi-layer, we call it multi-layer PCB board. It means we have four-sided, or just we call it 4 layers PCB board, and they have 8 layers PCB board. So let us take a simplest one, which is a single-sided PCB board. A single-sided PCB board, it just has 2 surfaces or 2 sides. One side will be the top view or the top side of the PCB board. Another side will be the bottom, Malaika. Another side will be what? Malaika was not in the class. So suppose that this side we call it the top side, and this is the bottom side. So the top side, this is the side where we place electronics components. We mount electronics components. Then the bottom side, this is the place where we find the copper that will actually create the traces or the roots to connect one electronics component to another electronics components. We are responsible to arrange the electronics components on the PCB board, and also we are responsible to interconnect them by using the copper material. So once you mount electronics components on this PCB board, the next step you have to do soldering. So soldering actually means that you attach those electronics components permanently onto the PCB board. And the soldering should be done on this side. On this side, just you have electronics components. I think that when we discuss about that, I'll bring some examples of the PCB board, of the single-sided PCB board and the double-sided PCB board. I think that will be easier for you to understand. But just to have an abstract idea, that's how we talk or we discuss. So the holes will be actual from the top side to the bottom side. When you talk about traces, if the single-sided PCB board will be always found at the bottom of the PCB board. When you talk about the electronics components, will be always found on the top surface of the OT of the PCB board. So the latecomer is still chatting. Class, are we together? Yeah. Are we together? Yeah. So you should have an idea about PCB board layout diagram. How are you? I'm fine. So the aim of the PCB layout diagram, PCB layout diagram is to show the physical, to show the physical layout of an electronics circuit, So it also represents the positioning and the positioning of electronics components, and the routing, positioning of electronics components and routing of conductive traces. So this is a simple discussion. The two sentences are very important. Listen, stop writing. The aim of the PCB layout diagram is to show the physical layout of an electronic circuit. So the aim of the PCB layout diagrams is not to show the concept behind the electronics, maybe the schematic circuit or that electronic circuit. The aim of PCB layout is actually to show how well that system look like physically after implementation. Okay?
Yeah.
Okay?
Yes.
So remember that if you want to know that how these how this resistor 1 and the 1 are interconnected, or how are they working, that's all about the schematic diagrams, schematic circuit diagrams, block diagrams. That's what I explained. But when it comes for the PCB layout, you are actually thinking about the appearance of the physical board, the appearance of the physical system after implementation. And when we talk about some other types of drawings, we mean that they actually explain in detail about the idea. Why do we have this block? Why do we have these components? Why should we interconnect them in this style? What is being done in this component? So the PCB layout is actually not focusing about functionality of the electronics components. It's actually focusing on the positioning of electronics components on the board and the routings. So you say routings means the interconnection between one component and another component. Between one component and another component. So simply from today onwards, in electronics, we can interconnect two components by either using electrical traces or by using electrical wires. So you may use a physical wire, or you may use copper material, which you call it traces or roots. Are we together?
Yes.
Then we say that all the PCB layout diagram are drawn by using computer aided design. By using computer aided design, aka CAD software or softwares. Example, can draw them by using Proteus, can draw them by using KiCad, can draw the PCB layout by using freezing, can draw the PCB board by using EasyEDA, etc., etc. So there's no way out. Stop writing. Stop writing. Good luck. What are you doing? Huh? So do you think that you are very intelligent more than me? What do we say in this sentence? All the PCB layout diagrams. Say all the PCB layout diagrams. Say all the PCB layout diagrams.
PCB layout diagram
Are always drawn by using computer aided design, or in short we call it CAD softwares. Say computer aided design or CAD softwares.
Computer aided design of software.
Of CAD is software. Say it again. 1, 2, 3, go.
Computer aided design or CAD software.
CAD is square.
CAD.
Say it again. I didn't hear it.
Computer aided design or CAD software.
I think you should leave the word of software because I just hear that card is square. Card is square. So you don't say software. Card is square. So we have square there. So there's no way out that you can draw this PCB. You can draw a block diagram by using a paper and drawing tools and your own hand. You can draw the schematic diagrams by using drawing tools, pencil, or maybe a pen or a taper or any drawing tools, and you can draw it on the paper. You may also use drawing tools and your hands to draw the circuit diagram. You may also draw the functional block diagrams on the piece of paper. But when it comes for the PCB layout diagrams, then for this case, you have to use a computer. And that's why that is important for you to have a computer. Okay?
Yes.
Because without a computer, you cannot draw. So all the PCB layout diagrams, all the PCB motherboards that you know in electronics, they have been drawing by using a computer. And that's one of the applications of the computer that you have or you are expecting to look for. Is it clear?
Yes.
Class, is it clear?
Yes.
Well, number 5. The 5th type, which is the second type of electronics drafting, is number 6 here. The 6th type, which is the second type of electronics drafting, we call it so it means that he printed circuit board. So it depends the number. This number 6, that number 5. So number 6 is called the wiring diagram. Wiring diagram. Say wiring diagram.
Wiring diagram.
We have discussed about wiring diagrams, but we just discussed the differences of what electronics drawings and the electronics drafting. So what is a wiring diagram? So a wiring diagram, we say that shows, so is a type of electronics drafting that shows how wires are connected in a system. In a system or devices. In a system or devices. Usual with more emphasis on the physical connection. On the physical connection. On the physical connection between components. Between components rather than the components themselves. Rather than the component themselves. So this is the simple definition of wiring diagram. We say that this is the types of electronics drafting that also focus on the physical constructions or physical layout of the system and actually shows how wires are connected in a system or devices. Usually it's more emphasis on the physical connection, of the components rather than the components themselves. Stop writing. Stop writing. The fifth C, I said, what did I say?
Stop writing.
Eh?
Stop writing.
Stop diagram. Eh? Stop what?
Writing.
Stop writing or stop drawing? Others are drawing. We say a wiring diagram, say a wiring diagram.
Wiring diagram.
So a wiring diagram is a type of electronics drafting that shows how wires are connected. So it shows how wires are connected in a system or devices. Usually with more emphasis. So usual with more emphasis on what? On the physical connection between the components rather than the components themselves. So when you talk about wiring diagrams, the main focus is physical connection between subsystem, particular subsystem in the motherboard, and another particular subsystem with the motherboard, of the same motherboard. Or maybe between the output peripherals and the motherboards, or between the input peripherals and the motherboards. So the main focus for these wiring diagrams is not on the electronics components, but the main focus on the interconnection between those electronics components in the PCB layout diagram. Stand up, stand up, stand up, stand up, stand up, and stand up. Something is going on there. Stand up quickly. What did I say? Tell us, what did I say? What did I say before I told you to stand up? Eh? I said stand up, eh? Yeah, so he just heard stand up. That's what he heard. So you could understand that what was going on. So, we say that the main focus in this wiring diagram is just the physical connection. Say physical connection.
Physical connection.
Say physical connection.
Physical connection.
Let me demonstrate this concept by using some students. I need 4 students. Come, including yourself and you. Malaika come, Naomi come, Diana come. Let me demonstrate so that you may have this concept. What's your name?
Enoch.
Enoch, Mr. Enoch. That is Diana. What's your name? Dan. Dan of Bong. Then that is Naomi. You, Mr. Who? Come this way, Malaika. What's your name? Musa. Musa. And then this is Malaika. Who is this? This is the angel. Ha! She's not a Malaika. So angel in English. You're an English person. Okay, well. So suppose that these are the electronics components. All of this, just come this way. These are the electronics components. So you have some electronics components here, and you have others here. Then you have another electronics components here. Stand here. Yes, you go. Then you have another electronics component. So these are the electronics components. Listen, when you talk about the PCB board, then these electronics components actual can be connected with another electronics components by using traces. And this one can be connected with this another electronics component by using traces. So this we call them traces, which are copper material. They are not wires. Okay? And then this one is connected with another electronics components by using traces. Then again, interconnecting. That's another trace. Or we call them roots. Then so for this case, we can have a complete circulation of electric current. So these are the electronics components, and these are the roots or traces. Okay? Yes. Okay? Yes. Yeah, so that's the meaning of PCB layout. And then another concept I'm teaching about wiring diagram. So in case of wiring diagram, we are using the copper wires, but we need the physical wire. We are not using copper on the PCB board. We are using the physical wires. And we'll be focusing on the physical connection. So the PCB board actually will also discuss or will actually focus on the physical layout or the physical side of that electronics component. But when it comes for the case of the wiring diagram, the main focus is not these electronics components. We are not focused on these electronics components, right? The main focus is on the wiring. How do we connect externally these electronics components by using wires? So right now, this is the wire, this is the wire, that the wire, show up your wire, and this is the wire, and this is the wire. So our main focus is not about how we place these components on the PCB board. The main focus is how we connect them externally. Say external connection.
External connection.
Yeah, because it means that maybe we have connected them internally, but we have we experience some limitation. So we should use the external wires actually to take a signal from one electronics component to another electronics component. Are we together?
Yes.
Is it clear?
Yeah.
Eh?
Yes.
Then congratulate these who have volunteered themselves. Congratulate them. Thank you very much. Next time we'll take you just to do the demonstration, okay? You'll be the next one. So tell your neighbor your AKA today is electronics component.
You are
Call your neighbor electronics component.
electronics component.
Huh?
You are electronics component.
So ask your neighbor, can you have a wire? Can you establish the wire?
Yes, I have.
So the main purpose, keep quiet. The main purpose of wiring diagram is oftenly or is used to assemble, or repair different electronics equipment, different electronics devices, etc., etc. So in most cases, we are using this to assemble. So in assembly, so assembly is actual to interconnect different parts. Okay? Then the seventh type of electronics drawings and diagram, which is the said one for electronics drafting, is called the pictorial. Pictorial diagram. Pictorial diagram. Say pictorial diagram. Or before we discuss pictorial diagram, let us discuss another types of diagram which relating with wiring diagram. Signal flow diagram. Signal flow diagram. Say signal flow diagram.
Signal flow diagram.
Say signal flow diagram.
Signal flow diagram.
So a signal flow diagram is a diagram that represents the flow of electric signal or electric signals, flow of electric signal through a system. Through a system or circuit. So a signal flow diagram is a diagram that represents the flow of electric signal. So this shows a flow of electric signal through the system or the circuit. So we expected that in those electronic systems, we expected the flow of electric current from one point to another point. So it may be asked you to draw the signal flow diagram, how the signal will be flowing. I mean that the main focus for this diagram is it shows the signal flow. Say signal flow. When you talk about signal flow, it's not externally, or it does not focus on the physical structure. It actually talks on the concept, how the signal will be flowing from one electronics component to another electronics component. Okay?
Yes. Yes.
So in these diagrams actually say that it shows signal pass. It shows signal pass. Shows signal pass, usually with arrows. Showing the direction of the signal. The direction of the signal. Signal transmission through electronics components. Through electronics components like amplifiers, like filters, like sensors. So you say it is used in audio system. Also it's used in radio frequency or RF system or circuits, and also it's used used in communication systems. So these are the places or are the types of the system where actually you may find the signal flow diagram. Separating. Say signal flow diagram.
Signal flow diagram.
What is signal flow diagram? Read the definition quickly.
The signal flow diagram is a diagram that represents the flow of electric signals through a system or circuit.
Well, so what does it show?
It shows signal path.
Remember, signal path is a little bit different from the physical connections by using wires. So for this one, it shows signals. When you talk about signals, signals are the signals which processed by electronics components. In most cases, we say that they're in electrical form. So the electrical form signals. And then its users usually use what? Arrows. Shows what?
Showing the
directions of the signal what?
Transmission.
Through what?
Through electronic
like what?
Like amplifier.
What?
Filter.
And what?
And
Sensors. Then this one is used in most, is often used in what? Audio what?
System.
Or radio frequency what? Radio frequency what?
Circuits.
And in communication what?
System.
So what does it mean? For instance, listen, you can have your fundamental electronics device, which is a resistor. Hello? Then you can also have another electronics component, which you call the capacitor. Then we can have another electronics component, which you call it maybe diode. So if that's the case, this is capacitor 1, this is the 1, for instance. Then we can have a DC source. Then maybe you can have a switch, for instance. So for this case, we say that this is switch K, this is the cell, or this is the battery. So if you draw in this style, actually this is called a schematic diagram. It's not a schematic circuit diagram, and also it's not a circuit diagram. But then if you want to know or you want to focus on the signal, we say that we have three electronics components. We have a switch and also we have a battery, which is the electrical component or electrical device. Then we have to think about how the signal will be flowing from one component to another component. You may have also another route. This is the junction. You may have another route. And then here you say that, okay, I'll be connecting an inductor with self-inductance of L1. So when you talk about signal flow, it means that our main intention is not to connect the components. Our main intention is to show the directions of the current. Okay? To show the directions of what? If we draw like that once, that is a schematic diagram. It's not a circuit diagram because we don't know the values of electronics components. We discussed about that in lecture 4. Again, this is not a signal flow. When you talk about these wires, these are just wiring. They can be either they be connected on the PCB board or a variable board by using internal connection or external connection. Okay? So if that's the case, we say that in case you want to represent the signal flow diagram, or we want to make the signal flow diagram, well, we have to show the signal path, usually with arrows, showing directions of the signal transmission. So what the kinds of the signal we transmitted for this case? It is electric signal, electric current. But sometimes in case of the communication or in case of the audio system, the signal which will be transmitted is not, it's an electric current, but actually carries information, which it is acoustic or sound signal. So when you talk about signal, we don't mean about current and voltage. It can be a particular physical information that will transmitted in another form. Stand up. Stand up. You'll go to your doctor. Stand up. So to show the signal flow, we always start from the positive terminal. This is the negative terminal. Then you have a flow of electrical current from positive terminal towards the first terminal of a resistor. Hello, Diana. Then again, for this case, this is the flow of current. This is the signal flow. This is the simplest diagram, but you can have a complicated communication diagram. And then your intention is just maybe the signal flow of data, maybe the signal flow of text, maybe the text of the signal is voice, maybe the text of the signal is video, how that video will be flowing from one component to another component. Are we together? Yes. So you talk about signal, you don't mean it's about electric, maybe electric currents or voltage. No. It's a particular or real-life information, but that real-life information should be converted into electric form in order to be processed by electronics or electric components. Then, at this point, you have a junction. Nehemiah. So, then after having a junction, maybe you can have a flow of currents in this direction. But also for this case, you have another flow of current. Hello? Let's come. Then for this point, we have this flow of electric current. At this point, you have a flow of electric current. At this point, you have a flow of electric current. Then the loop will be completed. So you may have two loops. This is the first loop, or this is the second loop. Are we together? Are we together? So now this is the representation for the signal flow. How signal will be flowing. It's completely different if I don't put the arrows. If you don't put the arrows, you did not show the directions of the signal. You just used the wires. But the direction might be either forward or reverse. Class, are we together?
Yes.
This is figure what? Figure 5. The signal flow diagram. The 8 types is called the pictorial. The 8 or the first type of electronics drafting is called the pictorial diagram. If you have a question, you may ask. So what is pictorial diagram? So a pictorial diagram is a more visual form, is a more visual form of electronics drawing where the electronics components are represented as realistic images. Close to the ear, physical image. Close to the ear, physical image. rather than abstract symbols. Rather than abstract symbols. The pictorial diagram or diagrams are easy to be understood by the beginners electronics engineers and the technician. Engineers and technicians. Especially when they are looking at specific parts or assemblies. Separating. Say pictorial diagram. Say pictorial diagram. What is pictorial diagram? We say that a pictorial diagram, you can see it. A pictorial diagram is a more visual form of electronics drawing where electronics components are represented as realistic images, close to the ear physical image, rather than abstract symbols. Rather than abstract
symbols.
Rather than abstract
symbols.
Let me explain the meaning of that. Separating. Separating. Let us start with a simple example of a simple semiconductor. For example, the abstract symbol of a diode is the abstract symbol of a general purpose diode. Okay, when you talk about abstract symbol, you say abstract symbol.
Abstract symbol.
Say abstract symbol.
Abstract
It means
symbol.
that the schematic symbol or electron schematic symbol of the electrons component. When you talk about the realistic image of the diode, realistic image of the diode or general purpose diode. Say realistic image of the diode.
Realistic image of
Say
the
realistic
diode.
image of the diode.
Realistic image of the diode.
This is the realistic image of the diode. So this realistic image of the diode, then you find that one terminal has a white color. So this color, it's a mark, shows that this is cathode. So this is the mark. So this, we call it, it's a mark. Mark of cathode. So this is what we call realistic image, the physical appearance. When you talk about realistic image, we mean about the physical appearance. And in this one, always the positive terminal is longer than the negative terminal. So this one, we call it, this is cathode and this is anode. So the anode terminal is always longer than the cathode terminal. So you'll find that if it's a schematic circuit diagram, A is a schematic circuit diagram, we are not drawing the schematic circuit diagrams by using the abstract symbols, but we draw the schematic circuit diagram by using realistic image of the electronics components. So this is the physical appearance of the diode. If I give you a diode doesn't look like this one. This is the abstract schematic symbol. So a diode, its physical appearance is just like this. So it is cylinder in shape. It has a white mark to show that this is the cathode terminal, and also it has two terminals. The longest terminal is anode, and the shortest terminal is cathode. Are we together? So when you talk about pictorial diagram, say pictorial diagram. Itself is used realistic images of electronics components. So for instance, another realistic image of the resistor. So the schematic, the abstract symbol of a resistor is just like this one. This is the schematic symbol of resistor. It's realistic image of a resistor. A resistor in most cases is look like a cylinder, but it's not a closed cylinder, but it's a cylinder. It's just a cylinder of the particular shape. So this is the physical appearance of a resistor. This is the realistic image of the resistor. And then, but the terminals for the resistor are always equal because you don't have positive terminal and negative terminal. Then you can find that in the middle of this resistor, you'll find the color band. Depends. It can be 3 color bands, or 4 color bands, or 5 color bands, or 6 color bands. So suppose the standard one, which is 4 color band, the first color band, the second color band, the third color band, and this is the fourth color band. So this is the realistic image of what? So realistic image of diode and what? And the resistor. And here you have realistic image of diode and what? And the resistor. So this is realistic. So if you say pictorial diagram, it uses realistic image of electronics components. Class, are we together?
Yes.
Question. Ask a question. Uliza swali. Okay, so the simplest homework that I would like, namalizia unaondoka. So the simplest task that I would like just to leave as a challenge to the student, this is the simple homework that I would like to leave it to you. It's a serious homework. Make sure that draw the pictorial diagram. So draw the pictorial diagram of figure what? Figure 5. So this is the schematic, this is the quality signal flow and the schematic circuit diagram or schematic diagram. It's called the schematic and signal flow diagram. So make sure that you transform this diagram into pictorial diagram. And then after that, you'll have a huge introduction. I think that I gave you more than introduction of electronic shorty drawings and electronic shorty drafting. Students, did you understand? Yes. Yeah. So if somebody asks you about, can you tell me about introduction? of electronics drawing? Can you say a lot? I say, if somebody asks you that, what did you learn in electronics drawing? Can you give him or her the introductions of the contents that we covered? Well, so I would like to say that this is the end of the topic called the Introduction to Electronics Drawing. Yes, the subject, the module is called electronics drawing, but we are supposed also to learn about electronics drafting. So that's why that I'm going to say that it's the end of the topic called the Introduction to Electronics Drawing. So I would like to welcome you in the next topics that will be called the block diagrams, that's the topic 2 or chapter 2. And it will be very interesting. We'll have a lot of diagrams. Make sure that you have drawing tools. You have a pencil, you have a ruler, you have a rubber, you have a sharpener, you have maybe a good drawing papers. Should have A4 and A3 papers, because actually we are going to enjoy drawings and presenting the electronics idea or the ideas in electronics engineering in high level. So if that's the case, I believe that I thank God who have given me a chance to teach you 6 lectures in the first topic. I want to tell you that you are the first class which actually I have taught to you in detail about introduction to electronics drawing and electronics drafting. In other classes, we just touch some few concepts and then we move into very interesting and interesting topics in this module. So I would like to appreciate you and thank you for cooperating with me, and I would like to congratulate you for being patient from the beginnings of this topic to the end. We did not cover the module, but we are still going on. We have just covered the first topic, so we have moved some extra mile. So I would like to appreciate you. Now it's the time for me to congratulate you. So today I just want to congratulate you for understanding lecture 5 and also for being the part of this topic from beginning to the end. So 1, 2, 3, then ongereni, imareni introduction. Wow. So thank you very much. Welcome in the next topic. In case you have a question about chapter 1, don't hesitate to ask it. But I want to tell you that keep the contents I have taught you for the rest of your life. You may take them easily. You may take them that just normal contents. But I want to tell you that one day on this, one day of your life, you will remember what I'm telling you right now. So, thank you very much. All I say, bye-bye.
Africa.